Welcome. My name is Tom Quaife, editor and associate publisher of Dairy Herd Management. We are pleased to have you join us today for a discussion of choline and its impact on subclinical ketosis. Choline is a vitamin-like nutrient that is gaining more and more attention. It appears that many cows are deficient in choline, so providing supplemental choline in a rumen-protected form can help prevent many of the problems that cows experience during the transition period, most notably fatty liver, but there are other potential benefits such as improved milk production, improved reproductive performance, and lower incidence of ketosis. You will be amazed from today's presentation how big the problems of fatty liver and subclinical ketosis really are. Today's presentation is sponsored by Balchem. At the end of the presentation, we will be taking your questions. To type in a question, go to the floating toolbar on the screen, then to the drop-down arrow to the right of the toolbar and choose Q&A. Any questions we can't address within the time frame allotted, we will address separately after the webinar. Now I'm pleased to introduce our first presenter, Dr. Garrett Oetzel. Dr. Oetzel is Associate Professor in the Department of Medical Sciences in the School of Veterinary Medicine at the University of Wisconsin-Madison. He earned his Doctor of Veterinary Medicine degree from The Ohio State University. Now at the University of Wisconsin, he spends a good share of his time solving nutritional problems on dairy farms throughout the state. He is a noted expert and researcher on subclinical rumen acidosis in dairy cattle, prevention of hypocalcemia in dairy cattle, and the effects of subclinical ketosis on dairy cow performance. It is this last area, subclinical ketosis, that Dr. Oetzel will address today. Garrett, we look forward to hearing your presentation.
Well, thank you very much, Tom. It's a pleasure to be involved in this and to present this information. And as Tom has already said, I'm going to go through information about how subclinical ketosis impacts cattle, and you'll be hearing more specifically about how choline gets involved in preventing this problem as we move on through the presentation. So we'll start out just thinking about how things work with ketosis in cows. And these are just cows in maternity pens here. And hopefully these girls know what's coming, because there's going to be remarkable metabolic shifts after these cows calve. And they're going to go from a positive energy balance to a very, very negative energy balance in a very short period of time. So as that happens, some of the cows will respond well to this negative energy balance, but some won't. And those are the cows that are going to come down with ketosis. Subclinical ketosis is the one we're mostly going to be concerned with here today. And by definition, which is always a good place to start, we're going to call it excessive circulating ketone bodies. And emphasis on these are the circulating ones. We can measure these, but there are no or without clinical signs of ketosis in these animals. And a big point to make right away is these clinical signs that we might see are very subjective. So if you're out in the barn or have clients who are out in the barn looking, maybe they can notice the decreased appetite, the weight loss, or decreased milk yield in these cows. But all these are things that are difficult to get a clear handle on, because decreased appetite based on what standard? We know they should be coming up. Weight loss, well, yeah, we know that weight loss happens to a certain degree in early lactation. When do we consider it excessive? Decreased milk yield, at least that's a little bit easier. Cows should be coming up, but maybe they're not coming up quite fast enough. So all these things are subjective, a little bit hard to make a call. If you're out looking at cows carefully, particularly in these smaller herds where you're doing some component feeding like we have in the picture here, you'll notice that these cows would have a dull appearance. They would be depressed. If you would listen to rumen motility, it would be decreased. They would have what we call a normal TPR, which would be temperature, pulse, respiratory rate. And that would be typical for cows with ketosis, but we don't want to make the mistake saying that every fresh cow who's off feed and looks a little bit off and doesn't have an elevated temperature has ketosis. That may or may not be the case. And particularly in our smaller herds, we can see exactly what these cows are eating as we go down the line, and we can get an idea if they're eating their hay better but refusing their silage or grains. That's a little tip-off in smaller herds that we might have ketotic animals. But again, we're looking almost totally at subjective signs and the skill of the producer to determine this. It's common to go ahead and add a cow side test before making a final diagnosis, and that's certainly a good thing to do. There are a lot of ways we can approach that. We can use a urine test. We could use a milk test. Most helpful, and something I want to emphasize here today, it's very useful even to farm level, is going ahead and using a blood test. And we have just one of these that works as a cow side test for ketosis. It's called the Precision Extrameter. It comes from Abbott Laboratories, and it measures blood BHBA on a cow side basis with very excellent sensitivity and specificity, meaning it does a very good job of picking out who these cows are. You need 1 drop of blood taken from the tail vein of the cow. You just apply the blood to the end of the strip here. It's a very, very small amount. The meter tells you when it has received the right amount, gives you a ketone reading in 10 seconds. Each of these strips cost about $1.50, and the meter, I've seen prices on the meter range from as little as $5 or $10 to as much as $80. So pretty small cost for that, and the cost for the strips would be more than a urine test, but probably less or about the same as the milk BHBA test would be a lot more accurate. So what we're doing here is we're talking about making a shift to defining ketosis not so much on clinical signs, but by the actual quantitative blood BHBA levels. So we can take away some of the fuzziness, if you will, about whether this cow has ketosis or not, and actually test that BHBA cow side. Not to say you have to on all cows, but certainly a step a direction that we're heading, and it certainly helped us understand ketosis a lot better in cows. So if we're going to go ahead and define ketosis by blood BHBA, we're going to wind up with, if you will, 3 degrees of ketonemia, the amount of ketones in the blood. So we're going to have 2 thresholds, an upper and a lower threshold, and 3 levels. So if a cow's BHBA is below the lower threshold, that's easy. We say she has no ketosis. If she's in the middle range between the upper and lower, we're going to call that subclinical ketosis. And if she's above that upper level, we're going to call that clinical ketosis. Now, I have to tell you, as a veterinarian, I don't like these terms that we have to go here, because we're really just using a blood level, and we're kind of ignoring whether or not there might be clinical signs. But these terms are well rooted in the language that we use, working with dairy cows, with vets and producers now, and we'll stick with them. But we will recognize that, whether these are truly subclinical or truly clinical might be something that would vary from person to person and even cow to cow. But this gives us a starting point. So what are these thresholds? So we got to start with the lower threshold, and we're using 1.2 millimoles per liter is easily the most common lower threshold. If you look at the literature, you'll see some slightly different numbers, a range of values between about 1 and 1.4 millimoles per liter for the lower threshold. And the reason these are a little different, besides just being different studies and different cattle, is it depends on which outcome they're using. They could be looking at when does milk yield drop, when does the risk for DA go up, when does the risk for the cow being removed from the herd go up, and also could depend on a little bit on days in milk when that cow is actually being tested. But they're all going to fall within this range. And that works well for us. And I would encourage people, sometimes it makes a nice little academic argument about which one to use, and just don't go there in the argument. I would say just use 1.2 and move on. And some people really say, yeah, well, if I used a different one, my herd might look better. But that's not a helpful discussion. Just use 1.2 and do your testing. The upper threshold is a little harder. We've been using 3 millimoles per liter or greater is our most commonly used upper threshold. How do we come up with that? That was subjective. And basically just a little bit of clinical work I had suggested that we should be seeing clinical signs when we're over 3. So I put a little notice about that in the literature, and people kind of grabbed onto it, and it stuck. So we're going to use 3 as our upper. So if they're over 3, we're going to call them clinical ketosis. Yeah, they should show clinical signs, But I'll tell you, particularly in larger herds, as we're going down the line, looking at these cows, hopefully reading the bunks, reading the cow's attitude and appetite, you're going to miss a lot of these cows that are even over 3 unless you go in and test for them. Another interesting thing in our smaller herds where we can really read the cows better and read which component of the diet they're eating or not eating, they'll tend to overdiagnose ketosis, and there are references to that in the literature. So doing the testing is always the place to go. So there's our start. I think we got a little idea what we mean by these forms of ketosis. Now I need to do a little epidemiology with you and talk about incidence and prevalence of ketosis, and we'll focus on subclinical. And I think once we explain this, it'll make a little more sense, but you have to bear with me as we do some classic epidemiology. I'm going to start with incidence, so we need to have a definition here. It's the number of new cases of subclinical ketosis. We're defining subclinical ketosis as BHBA between 1.2 and 2.9 millimoles per liter on that meter. And that is going to be during the risk period when cows are susceptible. And it could be any time during the risk period. If the cow goes over 1.2, if it's over 2.9, we call it clinical. That's the numerator. Denominator is the number of cows that completed the risk period. Now that may seem a bit complicated and a little difficult because it is. Incidence, and maybe a way to help you remember it, always involves time. It's not a single point in time. There are things happening along 2 aspects of time. First is what that risk period is, and it's early lactation for ketosis. That should be pretty evident. What we found is if these are TMR-fed cattle in group housing, which is where we generally are, we're going to say around 3 to 16 days in milk for the onset of ketosis will capture the overwhelming majority of them. However, if cows are in component-fed herds and they're individually housed, where they don't compete for food, they don't have the social pressures, it becomes more of a nutritionally based disease rather than what we have in the group housing, where it's more a matter of stress that's happening to cows and intake. And so out here in the component-fed herds, it's later days in milk, and actually physiologically it's a little different form of ketosis out there. So we have to know the type of herd before we know the risk period. And of course, for most of our herds, we're going to be looking in that 3 to 16-day range. And then there's a time period on the second part, which is just over what time period we're evaluating this incidence. And typically it's a year, what the annual rate would be in the herd. In a very large herd, we might be looking at monthly rates of subclinical ketosis, but you need a pretty good number of cows before you even start thinking about defining an incidence over that time period. So usually a year, but maybe a little less than that. Because this incidence can be any time that they get it during the risk period, you have to do repeated testing. And what we've learned from research is that means you have to test them at least twice weekly. It's very unusual for this to actually happen on commercial dairies, that you would do true incidence testing. The median time for resolution of a case of subclinical ketosis, this would be for cows that were not treated but just were allowed to let the disease run their course. Some didn't resolve it for a long time, but the median time was 5 days. So we need to test cows in order to be able to catch that high BHBA if it happens maybe 4 or 5 days. It could even be less than that. A lot of studies are going to report incidence of subclinical ketosis based on once weekly testing, and that's going to be a slight underestimation of the actual incidence of ketosis, because some cows could have had 5 days, resolved it, and then have tested negative on both sides of that. So that is one of the things that kind of clouds the literature, is that we tended not to do weekly testing. I will show you some research here in a little bit where we tested 3 times a week, which is much more appropriate for that. Even using weekly testing in some of these older studies, they report incidence of ketosis between about 40 and 60%. And that's been out there in the literature for a good while. And I find it interesting that as an industry, we missed that. And a number of years ago, I started making some noise in presentations and papers about this being a very high incidence disease, 30, maybe even 40%. The literature said it was even a little bit more than that. And as we look at our numbers, we can't be sure, but it would not surprise me. It would be a reasonable guess that we actually have about a 40% incidence of ketosis in our early lactation dairy cows right now. So this is a very, very common disease. So we wanted to study this some more. I'm going to refer quite a bit to a field study that we did summer before last, 2010. This is a collaborative study with colleagues at Cornell University. So a very talented PhD student, Jessica McCart, Dr. Paula Ospina, and then the senior clinician there or investigator, Dr. Daryl Neidham. So this is a group effort on this. I give great credit to my coworkers here. But we did a 4-herd study, 2 in New York, 2 in Wisconsin. We enrolled all the fresh cows in those 4 herds over the course of a summer. And we did very intensive ketosis monitoring on these cows after calving. We used the precision extra test for blood BHBA. It was 3 times a week, so Monday, Wednesday, Friday. We started the first test when the cow was at least after 3 days in milk, so the first test was between 3 and 5. They got 6 total tests, so they got 2 weeks worth of testing on this, so they ended somewhere between day 14 and 16. So we were able to calculate a ketosis incidence for each herd with what is very probably the most reliable incidence numbers ever developed in a research study because we did such frequent testing of our cows. So here's just the overall layout of the study and how it went by herd. So you can see we have 4 herds. We had our 2 New York herds over here. These were good-sized herds, 1,900 cows on these guys. So 400 cows enrolled. 1 herd had an incidence of subclinical ketosis. So the clinical ketosis is not in here. There's no clinical ketosis. So they're all between 1.2 and 2.9. And in this group in here, we had a 40% herd and a 26% herd. So probably an average and a very, very good one. And in our Wisconsin herds, these were bigger, but we had some different time periods. This was about a 2,700 cow herd with about an average incidence. And then we had a 4,100 cow herd where we enrolled almost 700 cows. And this was our problem ketosis herd, up around 56%. If you look at our study, the average was 43% incidence of subclinical ketosis. We also had some clinicals thrown in there over this time period. And again, these were not bad herds. They're very high-producing, well-managed herds with great records. That's why we were in there working with these folks and certainly appreciate their collaboration and cooperation with us. Okay, how did this work out in these herds is we looked at the incidence of subclinical ketosis by days in milk. So we have a tremendous amount of detail on this. And here's the numbers as they come out. And we could see when cows first developed ketosis. So we started testing over here at 3 days in milk, and the peak was at 5 days in milk, much earlier than what we would have thought it would be, and then it just goes down quickly after that. So these are the new cases of ketosis. They start very early in lactation. So we get a lot of insight from this study and what we did over there working through it. Okay, so that's incidence. Now we're going to go over here to prevalence of subclinical ketosis. This is the practical one. This is the one that we can work with. This is a snapshot, if you will, of the current subclinical ketosis status in a group of cows, the fresh cows within a herd. It's the number of cows with subclinical ketosis at a single point in time divided by the number of cows tested at that point in time. So if you've done with your herds or a client or on your cows some testing, you've almost certainly done prevalence testing just to see how many had it out of the number that you tested. It's a lot easier than doing incidence testing. You don't need anything repeated. You just go in once if you wish. You can do it multiple times. That will increase your reliability. That's what we call a cumulative prevalence. Usually you're just doing a subset of the early lactation cows. And when people talk about doing this kind of testing, it's almost always prevalence testing. But we have to think about this and be able to define it carefully so we know what we're talking about. If you go back to our study and looking at our cows where we did a lot of this testing, you'll see the prevalence of subclinical ketosis also peaked at 5 days in milk. And then it tails off after that, but a lot more slowly because this is just the number of animals that have ketosis at these points in time. But you can see again, both on an incidence and prevalence basis, it happens quite early in the herd. So why do we have to go through all this? Well, it's important that we be able to think about these two things and be able to characterize our herds and know what numbers we're talking about. And we really want to get at incidence. What matters to us, as consultants or dairy producers, is how many cows get it. But we're not going to be able to measure that. We're going to measure prevalence instead. But if we're going to do an economic evaluation and see how much money we're losing due to subclinical ketosis, or even to determine the best strategy, we need to know the actual incidence. But we're going to measure prevalence. Thankfully, the biology is very consistent here. From a couple of data sets, we can tell you the incidence of ketosis is 2.2 to 2.4 times the prevalence. So if you go into a herd, sample a large group of cows, and come up with a 20% prevalence of ketosis in those cows, multiply by 2.2, you could say, gee, we're somewhere around 44% incidence. That's how many cows actually get it. Only 20% have it today, but around 44 getting it sometime. Those would be pretty average kind of numbers out there. So there's the story on how that works. Now, what does it do to cows? What are the negative impacts of this, and why is it so important to prevent it? So we'll go through a lot of research data pretty quickly. First of all, we're going to talk about reduced milk yield, and this is the one that hits us the heaviest with this problem. And I'm going to start out by saying that we are underestimating the total milk loss, because whenever a research study does this, they compare the milk production in the non-ketotic cows to the cows with subclinical ketosis. We don't have any way of accounting for the fact that higher producing cows are already at higher risk. So we don't know how much the ketosis cost that cow. We just know how the ketotic versus non-ketotic did. So I'm going to show you numbers and just tell you biologically, those are very, very conservative numbers. So things that are out there from studies even that go back to the 80s, 4.4 to 6.6% for different groups, 5.5 to 7, another 7. And then our study that we recently did was 3.4. And we think our study was a little lower on the milk loss because we did more intensive testing and we caught some of those even milder cases. But across the board, it's at least 3.5% and probably reasonably as much as 5 or 7 when they get that. Other things we've learned about milk yield loss, and I think partly this just shows us how strong this biology is that the severity of the subclinical ketosis affects how much milk yield they lose. And so when you first test the cows and they first are identified as being ketotic, we know as it goes up, it gets worse. For each 0.1 millimole per liter increase in BHBA, you lose another 1.1 pounds of milk lost. And we're just looking at milk in the first 30 days in milk. We pulled those off daily milk weights. We can go ahead and show you how this looks when it's all graphed out. It's really pretty amazing. So these are cows down here that just barely got in. They were ketotic. They lost milk yield. But it moves down in a surprisingly linear fashion. We first saw these data, and I tell people we really didn't make them up. By the time we get out here with cows that are still what we call subclinical ketosis, but they're higher, we've been losing over a pound increment. So there's 13, 16 pounds of milk across this scale. Pretty linear. So very strong biology here. The higher the BHBA, the more milk we lose. Another thing we learned looking at our big study that we did where we had all this sampling 3 times a week was that when they got it, days in milk at onset of the ketosis greatly affected the magnitude of the milk loss. And this is intuitive. You might have guessed that if they got it early, and our break point was cows that got between 3 and 7 days in milk when they first were determined to be ketotic, gave 6% less milk than the cows who got it later. So here we're comparing 2 different kinds of ketotic cows, and we're seeing a pretty big difference. So cows, when they get it right away, or if they get very high BHBAs, those are the cows that are going to suffer even more. We did do, as part of our study, a treatment trial. So we randomly assigned half of our cows with subclinical ketosis to receive a treatment, which is 300 ml of propylene glycol, or PG, once a day, until they tested negative on the meter. And we reduced those milk yield losses by about half by doing the treatment. So we could show that the treatment was very, very helpful. Another thing that happens on these cows, and it's, okay, we flip back to one slide, but I don't think so, is that we increase the risk for displaced abomasum. We also decreased the risk for turnover. when we had cows that didn't get ketotic. Now we're going to show you the DA data. And there are several earlier studies. This is a classic outcome that we have with ketosis. And we had studies that show that cows that are ketotic 2.6 times greater odds. There was a study that did risk ratios at 7 times. When we did our study, it was 19 times greater risk for DA in cows that were ketotic. And there was one large study out of the group at Ontario at Guelph where they didn't see any effect of BHBA on DA risk. But in general, we know it's there. And these numbers seem kind of different and big, but when you have a very low incidence disease like DA, you're going to see wildly different risk ratios or odds ratios. So we weren't too concerned about that popping up. Again, trying to do a little back check on our biology here. The more severe the ketosis, the more likely they were to get a DA. As we went across the range of BHBA for subclinical ketosis, about a 4 times greater risk for those higher BHBA cows than the lower ones. So again, made sense, and earlier onset increased the risk of DA, about a 6-fold increase in the risk of DA. And here our break point was on that first test, 3 to 5 days in milk versus the 6 to 16, or the cows that got it a little bit later on. Another way just to show how strong this biology is we did the early detection and treatment. The cows that got the treatment were 1.6 times less likely to even get a DA. So we didn't take all the DA risk away, but we took a good part of it away. So that's an important aspect to this. Increased risk for metritis is out there in the literature. I will say that this is a hard outcome to evaluate because ketosis and metritis occur very much around the same time, 5, 6, 7, 8 days in milk. So it's hard to tell which one came first, especially with metritis being a very subjective diagnosis. So in our study that we did in 2010, we actually didn't even look at that. We actually used metritis as a covariate rather than an outcome. But other people have looked at it. And I think the biology is right. 3.4 times greater odds for metritis if you had subclinical ketosis in one of the Canadian studies, and then a study out of New York was 2.3 times greater risk. And this does make sense. Ketosis is very immune suppressive to dairy cows. I think there are 3 big signals to a cow that can tell her that she's got to slow down her immune function. Parturition is one of them. All cows around calving are pretty immune suppressed. Negative energy balance is another signal that we're short on calories, so don't divert too many calories to immune functions, which can take a lot. But ketosis is a 3rd signal, and it's actually a very strong one. And metritis, the risk for metritis depends very, very much on the cow's immune status. So I think it's a good piece of biology, good hypothesis that we do have higher risk for this, but we also have to realize and be a little tempered because we know that these diseases occur about the same time. So we may not have exactly which one came first, but they're certainly related. The last effect, the negative effect of ketosis I'm going to talk about is impaired fertility. And most of these studies are going to look at first service conception rates, where we can get a cleaner look at what's happening as we move on down to later services. There's other complicating factors. And I'm going to describe this effect as inconsistent. I'll show you some data, and I think we have a bit of an explanation here. So here's a study from some Canadian cows. This was actually a 1990 study, and they looked at the repro part later. And they did show that if cows had subclinical ketosis, they were using a pretty low threshold at the 1.0 level. They were 0.73 times more likely to conceive. And so this is an odds ratio below 1. What that means, it's a little hard to interpret, but they were 27% less likely to conceive. In that same database, if they got out into the 2nd week, so this one was first week, but then they got the 2nd week, the threshold was higher, and the odds was 0.6, so 40% less likely to conceive. So very strong effects. And when we saw those data, we got pretty excited about this particular relationship. I'm going to tell you that it's not held up in newer studies. There was a 2010 study in New York where they just had a trend. We wouldn't call this significant at p equals 0.1, but a trend toward lower conception. They were doing hazard analysis here of 0.89, so 11% less. But the 2 most recent studies, the Chapanel study, which was about 2,400 cows in a lot of different herds, and our big study that we did in published in 2012, saw no effect of BHBA on conception rates. So what might be happening here? Because as we move forward in time, it seems like we're not seeing it. We're seeing as much ketosis, but not the repro effects. And I would suggest that it's our ovulation synchronization programs that are doing this, and that they're actually masking the effects of subclinical ketosis on fertility. Because these later studies were done in larger herds. In our study with 4 herds, they were all on an OVSYNC type of program. And when you do that for a cow, it overcomes what's likely the 2 things that happen with ketosis and repro: a failure to cycle, and we can initiate that hormonally and overdo that, and then poor estrus display. And we can also override that because these are mostly timed inseminations. So that's our theory for why we're not necessarily seeing it when we use these ovulation sync programs. And there is another thing that would kind of support this, and there are lots of data that say that lame cows are equally fertile to non-lame cows in herds or in situations where they have an ovulation synchronization program going. That would seem very counterintuitive until you realize it's the same thing that we talked about with our ketotic cows. When we do the OVSYNC programs, they are forced to go into their cycle, and we don't have to see them display heat. So that's what we believe is happening there. So we're going to finish up with economic impacts, because we can show you some science and biology. If it doesn't make economic sense, it doesn't make sense at all. So what would the number be? Well, it's quantifiable. We could all figure out that there's a cost associated with this, but the issue is these inputs are highly variable. You've got milk yield loss, but we know there's a range. You've got feed costs, but we know there's a range there, and then there's going to be a feed efficiency that varies. The background incidence of diseases related to ketosis could vary, and where you start really determines how much you actually get rid of in a herd, because you might reduce the risk a certain amount. But if you started at 0.5% and you reduce the risk by half, that's not very many cases. The literature is going to give us a range of how many of those diseases, or how much the risk is affected, how much it costs. It depends on many things: the value of slaughter cows, disposal costs for dead cows, treatment costs, et cetera, and bringing in those herd replacements. So you're going to see numbers with ranges on them, but it'll at least give us some idea. So there are 2 Canadian studies that estimated the cost of subclinical ketosis, and these numbers have been adjusted for currency and for inflation. So Duffield's group had $46 to $92. There's another Canadian study that said about $68 per case of subclinical ketosis. When we did our study from the summer of 2010, we used very sophisticated modeling where we could look at all these input variables and account for what the changes might be in those, and then run different scenarios for what the cost would be. We actually would do 10,000 runs of different input costs, came up with a mean cost of $67 per case, which is very reassuring because it puts us in the range of the others. More usefully here, we get a 95% confidence interval that even on the extremes, it's a $33 to $109 problem. So it's almost always going to fall within that range and always be a considerable negative. So if you think about this, if you got a 40% incidence of ketosis in average herd, you're losing $30 per cow for every cow. And we have interventions that we think you can reduce this at least by half in most of these herds. So what would be those things? We know the value is really high. So it starts with fatty liver. That's our underlying cause. And so things that would contribute to that would be stress, excessive or premature negative energy balance, overconditioning, and then a lot of really important nutritional factors come in here. So if we can prevent this, we're going to help keep this incidence of subclinical ketosis down. And this isn't a talk about those things, but we're going to just emphasize and kind of highlighting that it's first about minimizing social stress, pen moves, other stressful environments, especially in that 2 to 9 day period prior to calving. Adequate bunk space. So we say it's essential not to overcrowd pre- and post-fresh cows. That means 30 inches of bunk space per cow for adult Holsteins. Adequate access to feed. Consistent feed refusals, always getting some, especially in that pre-fresh group, where we just never want those bunks to run empty. And then your feed additives can always help. And choline and monensin are the 2 that have got good research which show the benefits of these guys. So that would be the information that I have on the effects, and I'm going to turn it back over to our other speakers.
Thanks, Garrett, for sharing your insight on subclinical ketosis. Our next presenter is Dr. RIC GRUMMER, Ruminant Technical Director for the Balchem Corporation. Dr. GRUMMER obtained his bachelor degree at the University of Wisconsin-Madison and his master's and PhD degrees in dairy science at the University of Illinois. After becoming an assistant professor in the Department of Dairy Science at the University of Wisconsin, he progressed to the rank of professor and served as the chairman of the Dairy Science Department at UW-Madison from 2004 to 2010. In September 2010, he retired from the university and joined Balchem as Ruminant Technical Director. In that role, he provides technical service and research and development support and assists in expanding the global market for Balchem's animal health products. Dr. GRUMMER has published more than 100 peer-reviewed journal articles and 9 book chapters in the area of dairy cattle nutrition, with particular emphasis on transition dairy cows and metabolic diseases. Rick, the floor is yours.
Thank you, Tom. When we think of essential nutrients, we are typically thinking of things like amino acids, such as lysine and methionine, vitamins such as A, D, and E, perhaps the minerals, both the micro and macro. But choline really doesn't fit into any of those categories. Choline is often considered a vitamin, but it doesn't quite technically fit all the criteria. So, as Tom mentioned in the introduction to today's session, it's often referred to as a quasi-vitamin. Choline has many roles in the body, and we're not going to have time to discuss all of those. Perhaps one of its most important is a constituent of phosphatidylcholine. Phosphatidylcholine is a phospholipid. It's present in cell membranes, and therefore it's actually present in every cell in a cow's body. It's also part of lipoprotein particles, which are needed for transporting fat through the bloodstream. And that's one of the roles that we'll be focusing in on today. In 2001, NRC did not include choline as a requirement for adult cattle simply because at that point in time there was very, very little research on that particular nutrient. And so therefore they passed. But now we're almost, a dozen years or so past the publishing of the last NRC, so maybe it's time to reevaluate. And so today we're going to discuss the fact that it does indeed probably provide an essential nutrient that is deficient for transition dairy cows. What's an essential nutrient? Well, it's a nutrient that is required for the body, by the body for normal functioning. It's a nutrient that either cannot be synthesized by the body at all or cannot be synthesized in amounts that are really sufficient for adequate or good health. So with that as sort of a background on what we're talking about when we're referring to an essential nutrient, it really boils down to two really important questions when trying to determine if it is an essential nutrient, and that is, do cows, now we're talking specifically on transition dairy cows, do they exhibit the deficiency symptoms, number one? And if they do, can those deficiency symptoms be alleviated through the supplementation? So to question number one, do they exhibit deficiency symptoms? Well, what is the classic deficiency symptom? It's fatty liver. In every species that it's been studied in so far, fatty liver is the number one deficiency symptom. So how does that relate to the dairy cow? Well, the pink circle over here really refers to the liver, and we know that during certain times of that cow's life, namely during the time of calving, when she goes through a lot of stress, And shortly after calving, when she's in negative energy balance because she can't eat enough to meet her energy requirements, she mobilizes fat from her back. And we call those fatty acids, as they come off of the back, non-esterified fatty acids, or NEFA. And we know about 30% of those NEFA that are peeled off the cow's back actually will go to the liver. Now, there are several different fates for NEFA. Some of the NEFA are actually oxidized as a fuel, but the liver cells only need so much energy or so much fuel. So after that requirement's been met, they begin to convert those NEFA back into triglycerides, which hopefully can be packaged into what's called a very low-density lipoprotein particle for export out of the liver, and then that VLDL particle can carry that triglyceride or that fat to the mammary tissue where it can be used as an energy source or for milk fat synthesis. Well, for that whole process to occur, not only is the triglyceride an important constituent of that VLDL particle, but there's other constituents such as protein, cholesterol, cholesterol ester, or in this case, phosphatidylcholine. And it's been shown that if you do not get enough phosphatidylcholine derived from choline, that this whole process can break down. And rather than exporting the triglyceride out of the liver, then the triglyceride gets deposited and the cow develops fatty liver. And there's really a wide body of literature that supports that if you don't get enough phosphatidylcholine synthesis, this whole system breaks down. So, do these transition cows exhibit the deficiency symptom of fatty liver? I've got several studies here in several different countries with several different genetic bases for their cows, several different management systems, and there seems to be a very consistent 50% of our fresh cows will have what's called moderately or severe fatty liver. So basically 1 out of 2. And when they get up to that point of moderate to severe fatty liver, we're talking about 5% or more fat. And this is how the veterinary community likes to classify the liver as being moderate to severe in fatty liver. So it's very consistent, and if you take all the studies together, the range always seems to be 40 to 60% of fresh cows will have this severe or moderate fatty liver. So why are cows so susceptible to fatty liver? Well, number one, as we'll show you, the hepatic requirement or the liver requirement for choline is very high. The availability of dietary choline to the cow is very low. And if the cow can't get choline from the diet, then it has to synthesize it with it in its own body, and in all likelihood, that is probably insufficient. So on this graph, I'm showing a very nice study that was done by Chris Reynolds, where he actually measured fatty acid uptake by the liver as the cow goes from the dry period to early lactation. And you can see here that the cow's at around 100 grams of NEFA or fatty acid uptake per day during the dry period. And then all of a sudden on that day of calving, it goes way up. In this case, there was a 13-fold increase, up to 1,300 grams of fatty acid taken up by the liver. The reason it's so dramatic on the day of calving is because that cow goes through all sorts of hormonal changes associated with having the calf, associated with initiating milk production, that the signals to the fat back of the cow are is to release NEFA. So it literally goes through the roof. Then after calving, the NEFA will still stay elevated, and the reason that they stay elevated then is because the cow simply can't eat enough to meet its energy requirements, so she continues to mobilize fat off the back. So what we see then, if we take cows and we measure liver fat during the transition period, you'll see that shortly before calving there's a gradual increase, but boy, on that day of calving, when those NEFAs go through the roof, that's when you get the greatest accumulation of fat in the liver. And then after calving, again, when she's in her negative energy balance because she simply can't eat enough to support milk production, she may still have continued increases in triglyceride or fat in the liver. Jim Drakely at the University of Illinois went ahead and took a look at this process that occurs around the time of calving and concluded that by the day after calving, that liver may have accumulated 1 pound of fat. Well, the normal weight of a liver is about 20 pounds, so if you do the math very quickly, 1 divided by 20 gives you a 5% accumulation. That occurs basically by the day after calving. And again, that's that cutoff for defining moderate to severe fatty liver. When the cow loses body condition score, she's mobilizing fat, and if she loses 1 body condition score loss, that will deliver another 10 to 12 pounds of fat to the liver. Now, all that doesn't get deposited. Some of it is oxidized and serves as a fuel source. Some of it is exported. But it just shows you the continual stress and strain on the liver of fat delivery and potential for deposition. So, clearly the demand is high for choline, but unfortunately the intake and absorption of choline by the small intestine is very low. This was an experiment done many years ago by Richard at the University of Maryland, and in this experiment he fed a basal diet without any unprotected or free choline being added to the diet, or he went ahead and supplemented with a little over 300 grams of unprotected or free choline. The red bars, which you can hardly see here, is the amount of choline that got to the duodenum of those cows. And even if you flood the system by adding massive amounts of free choline, you basically can't get more than a couple of grams of choline to the lower gut of the cow. And here lies the problem, that there are rumen microorganisms in the rumen that are very active in degrading choline. And because of that, then we get very little getting to the lower gut. So let's go on to question number 2, and that is, can the deficiency symptom, namely fatty liver, be alleviated when we supplement with choline? And when we supplement with choline, we need to do it in a protected form. All right? So this is just the latest research that was done. There's several studies here. Basically, they took a group of transition cows. They fed, in this case, it was 15 grams of choline in a protected form from 3 weeks pre-calving to 6 weeks post-calving. Made sort of your standard measurements of milk and feed intake, some blood measurements into a subset of these cows. They took liver biopsies before treatment at -3 weeks, 1 week, 4, and 6 weeks after calving. And in this experiment, one of the measurements they made was the amount of fat in the liver. And this is what they found. I've got the 60-gram dose here because the product was actually 25% choline. The rest was the coating that goes around the choline. And you can see at week 1 and at week 4 after calving, there was a significant reduction in liver triglyceride when feeding protected choline. This was about a 35% reduction, and all told, across the studies that have been conducted, we can expect to see anywhere from about a 35 to a 50% reduction in fat in the liver. So we know they exhibit the deficiency symptom. We know if we feed them protected choline, we can alleviate it. So who cares, right? I mean, cows get fatty liver. What are the ramifications of it? Does it convey anything to the animal of economic importance? Well, you just heard the story from Dr. Oetzel about ketosis. The relationship between fatty liver and ketosis is there, and certainly that's one of the things. But let's take a look at it in a little bit more detail. From again, more of a cellular standpoint, we know because of a study done many years ago that when these liver cells get engorged with fat, they look strange, a little bit bizarre. The organelles, some of the important ones, such as the mitochondria, just don't seem to be right. Work that was done at the University of Wisconsin showed that some of the key functions of these liver cells is impaired. Probably the most important one is they're less able to make glucose, and glucose is an important precursor for milk lactose, and it's really the lactose production that drives milk production. So let's go on and talk about what happens to milk production, the immune competence of these cows, or the reproductive efficiency when having fatty liver. On this slide, we're looking at first service conception rate in several studies. The first one was done at the University of Missouri. 2 treatments, control animals versus those that were fed with a ruminally protected choline. And in this study, there was really an astronomical increase in conception rate. To be quite frank, probably too big to be believable. It was statistically significant, but because of the low number of cows involved in this study didn't catch on and take a lot of credence. Later on, Jose Santos at UC Davis did a study with 362 cows, saw an increase, but in this study it wasn't statistically significant. The middle 4 studies are studies that have been done on commercial dairy farms. There were not statistical analysis done that were associated with these studies, but you can see that in every case there were improvements in first service conception rate. So we think there is the potential for that, and right now a very large study is being conducted with actually 1,100 dairy cows per treatment, so we should have some further information on that in the future, but certainly at this point in time it looks very positive. This, again, is results from a University of California Davis study, Jose Santos, in which they fed ruminally protected choline from 3 weeks prepartum to 80 days postpartum. You can see the reduction in clinical ketosis from 11 to 4, the reduction in relapses, cows that had clinical ketosis that experienced a second bout, and a reduction in the subclinical ketosis at day 1 and day 14 postpartum. This is combined data for multiparous and primiparous cows. The effects were actually much greater for the multiparous cows than they were for the primiparous cows. As far as retained placenta, no difference there. Metritis, no difference. DA, no difference. Here comes this immune responsiveness issue again with mastitis. There was a drop in mastitis. If you took all of these diseases, combined them with the ketosis data, you got a highly significant reduction in disorders or diseases. This is fatty liver as defined by 5% fat or more in the liver, and you can see a very large reduction from 40 down to about 14%. This is work that I just did in conjunction with Peter Crump, a statistician at the University of Wisconsin, where we took all the data from 13 transition cow studies that have now been done supplementing ruminally protected choline to try to take a look at the effects on milk production. In 12 of these studies, the choline was fed both pre and post-fresh. In one of the studies, the supplementation was terminated at calving time. If we take a look at the results, the average intake, and this is postpartum feed intake, was about 1.6 pounds per day, and this was highly significant. If we go ahead and take a look at milk yield, the increase was 4.9 pounds per day. Again, highly significant. And for those of you that are not familiar with p-values, a p-value of 0.0001 means that if you declare those treatments as being different, you have 1 in 10,000 chances of making a mistake in that conclusion. So very, very highly significant. This shows the milk yield per study, and each line represents a study. So, for example, in this lower line, they had a 0 dose as their control, and it looks like about 7.5 grams of choline fed per day. This is a study in which they had 1, 2, 3 different doses. But if you take a look at these studies, and across these studies, you realize the amazing consistency in milk response, and that's why the p-value is so low. And I think it's important to point out that these were studies done by universities. They were done on well-managed herds. They were not done on herds that actually had issues with fatty liver and ketosis. So this really shows a response that might be related, again, to this whole biology of fatty liver, but yet, in fact, again, it was observed in kind of your standard type of herds. There were no significant increases in milk components. There were some slight numerical increases, so that when you express milk production on an energy-corrected basis, the increase was 5.9 pounds. One question I often get is, can methionine replace choline for reducing fatty liver? Metabolically, they have some similarities. Like choline, methionine is a methyl donor, and in fact its methyl groups can be used to synthesize phosphatidylcholine from phosphatidylcholine and ethanolamine. So it's a possibility there that there's some overlap. Methyl groups can also be used for the synthesis of carnitine, which are also involved with fatty acid oxidation in the liver. And methionine is an amino acid, and amino acids are needed for apolipoproteins, which are constituents of VLDL. As we look at the next slide, the one thing you got to remember is that 1 gram of choline is equivalent to about 4.3 grams of methionine on a methyl donor basis. So when we think of supplementing about 15 grams of choline, you need to compare that. An equivalent dose in methionine might be closer to around 60 grams per day. But I did want to show you, and we'll go over this very quickly because it's quite a busy slide. The first 4 studies here have been feeding a protected methionine in one form or another during the transition period. And the bottom line is that in these 4 studies, 2 of them there was no treatment effect. The 2 studies where there were significant effects, it was actually a slight increase in liver triglyceride. This final study was done in feed-restricted cows, feed restriction to induce fatty liver, and again, there was no significant difference. So it doesn't appear that methionine can replace choline for the prevention of fatty liver. I do point out that in these 4 transition studies that they did observe some sort of a production response indicating that, yes, methionine was getting through to the bloodstream. It also highlights the potential role for methionine in transition cows. All I'm saying is that it can't replace the effect of choline in reducing fatty liver. So, in summary, cows have great changes in energy balance, increases in fatty acid mobilization. It's just part of the normal biology of the cow. Clearly, cows are deficient in choline, as evidenced by the increase of fat in the liver during the transition period of time, and clearly that can be modified by supplementation of choline in a protected form. Choline in a protected form enhances cow health and performance, and it's an essential nutrient that should be really supplemented to all transition dairy cows. Historically, choline has been thought of as a feed additive used in problem herds or with problem cows, fat cows, herds with ketosis. But clearly, when we look back at even those milk production responses in normal herds, it goes beyond that now to the point where we need to think of it as an essential nutrient, just as we would calcium, phosphorus, A, D, and E, and that there's a role of it in all transition dairy cows. And with that, I'll quit here, Tom, and turn it back over to you.
Thanks, Rick, for telling us about the important role of choline. Now we'll take a few questions from the audience. And if you haven't already submitted your question, please do so in the box on the screen. The first question will be for Dr. Garrett Oetzel. Dr. Oetzel, I'm interested in the ketone test strips you mentioned. Where do I get them? Are they readily available?
The test strips are available both on the human market and to veterinarians, through veterinary distributors. You'll get the best price by far through a veterinarian coming through a veterinary distributor, in that range of around $1.50 per test strip. There have been some backorder problems with those recently because dairy producers are really using these and purchasing them a lot. The company's aware of it, wants to address that. So if there is a backorder issue, hopefully that will be resolved. But please don't give up on the strips. They really work well. And talk to your veterinarian. It's where you likely get the best price.
Okay. And the next question is for Dr. Grummer. What is the recommended dose of protected choline, and what is the recommended time of feeding?
A good question. I'm going to give you the recommended dose in grams of choline. And the recommended dose is 15 grams of choline per day. But remember that these choline molecules are protected or encapsulated with some sort of protectant. So usually then you have to back calculate how much of the actual product that's being marketed that you have to feed. So if the recommendation is 15 grams per day and the product is 25% choline, that means you have to feed 60 grams of the actual product being sold to the dairy producer. So that's something that you have to pay attention to. And again, you always have to make sure that whatever product you're using, that it has sufficient research to show that indeed it is protected and it works in the animal. So make sure you do that. The recommended feeding time is 21 days pre-calving till 21 days post-calving. And really what we're trying to do is to ensure that we have choline in that cow's system when she's going through the big changes in NEFA in blood, the big changes in the delivery of NEFA to the liver. So when we take the uncertainty involved with the time of the calving process occurs, plus the typical management system for many of having a 3-week close-up period, we say 21 days pre to 21 days post-calving.
Okay. There's another question that kind of follows from that, Dr. Grummer, and that is, how should protected choline be incorporated into the diet?
Well, of course, with TMRs being fed on many farms, we would advise to go ahead and incorporate the rumen-protected choline right into the TMR. Because it is added in such a small amount, we don't really recommend adding it directly. It's recommended that it be put into some sort of a pre-mix first so that there's just more of a volume that the choline is being put in with the TMR so you get better mixing. Of course, not everybody can or wants to feed as part of a TMR, either in a stanchion situation or in free stalls with headlocks. There's no problem with top dressing rumen-protected choline. It tends to be very palatable, and in the rare instances in which it's not consumed, all you do is kick a little feed over it, and that seems to mask any aversion to it at all. But it's really quite highly accepted in a top dress situation as well.
Okay, and then this question would be for Dr. Oetzel. It seems that the incidence of subclinical ketosis is much higher than I expected. Do you have a sense that this incident rate has increased over time, and what could be contributing to this increase?
Well, we don't have a lot of good studies, Tom, that go back in time, but what little we do have from back there would suggest that it may be up, but not that much. I think this has been with us for a while, and we just didn't know, and we're not paying attention to what was going on there. As we do more sophisticated testing, and clearly in our study, we were well over 40% just for the subclinicals. I do believe that it's quite likely, as we have put cows into group housing, and as we have fed them as groups rather than individuals, so they have to compete for eating space, they compete for lying space. We sometimes don't keep feed in front of them all the time. We stress them by moving between groups. Those are just features of larger TMR-fed herds, and I think we probably have increased our risk in that situation compared to smaller herds where cows were fed individually.
Okay, well, thank you. Time won't permit any more questions right now, but again, please submit your questions, and we will be sure that the speakers get an opportunity to see those and hopefully get back to you. Once again, thanks to our presenters, Dr. Garrett Oetzel from the University of Wisconsin and Dr. RIC GRUMMER from the Balchem Corporation. And a special thanks to our sponsor, Balchem. And watch for some more free webinars from Vance Publishing, parent company of Dairy Herd Management, that will be between now and a year from now. Thank you once again for attending. This webcast will be available within 2 days at www.dairyherdnetwork.com. You can send additional questions to the email dairyherd@advancedpublishing.com or post your question on the Dairy Herd Management Facebook page. And please take a few moments and complete the survey to help us better in the future. Thank you very much.